Well, gotta act fast. Sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip. We're in partnership with the folks from the IPC. Stakeholders unite and feel alright. Digging multi-show synergy. So let's all connect. Come on, people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine. Check us out. Virtual attendance. Yeah.
Making connection. Hi, Kelly Dack, back at you with AltiumLive Connect 2022. We're down here in beautiful La Jolla, California at the Altium headquarters, and we're coming up on the final keynote of AltiumLive 2022, and so we're checking in before the event because we thought it'd be a good idea to introduce you to one of the our keynote speakers, Zach Peterson. Zach, if you've noticed, has been all over the media world. He's such a good personality to express things technical in such a boom, 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 powerful way that just reaches us. So look who's here right now. Zach Peterson, welcome. Thanks. So good to talk to you.
Well, thank you for saying such kind words as I join in.
Oh, come on. Hey, so it turns out we have a little history. We go back a little bit, like through all last year. It turns out I had moved my place of employment, and I work at a new company now, and it turns out through the fickle finger of fate that Zach happens to be this company's second source, outside source for design overflow through Northwest Engineering Solutions. And you're also the technical consultant for Altium. And it's just, wow, how things come together. And now here we are talking to each other side by side on the broadcast here. So isn't that wonderful? Say yes.
I know, that was so funny. I remember that first client call I was having with those guys, and they said, "Oh, our new designer, Kelly." And I was like, wait a minute. Had to pause for a second, and then you jump on the phone.
Yeah. You're probably thinking, well, Kelly doesn't use their software. This could be a good thing. I might start getting a lot more business, which it's amazing. It's amazing that you, like I say, we've worked together. We've sent you work, and we've been able to discuss on the phone, and you've responded, and it's just been so well. So I just want to give you kudos for that. And you are doing such a great job in the podcast, and your clarity and your points you make, and these things just move. And I want to give you another nod for that. And things come in threes. In my brain, things work in threes. So the third thing is I want to give you a nod for your upcoming presentation. So tell us, maybe you can give us a preview. Let's pull some of our viewers into the keynote, the last keynote of AltiumLive Summit 2022. Tell us what we can expect. Don't give it all away here. We're just flying over. And then I may be asking you some more questions about it.
Yeah, so I mean, the title of the talk is where high speed meets high frequency, and really the central idea is to explore where some of the high speed signal integrity problems actually relate to high frequency problems, but then also use that to inform high frequency designs. So there are some design tips for high frequency. There's some thought processes and analyses for dealing with high frequency. And some of those same thought processes actually fit into analyzing and understanding what happens with high-speed signal integrity. So it is both conceptual, kind of from a high level, but I do my best to make it accessible, and then also practical. There are actual things that you can start doing if you have to do high-frequency designs.
Yeah. So
and I even show a couple of examples from. Oh, sorry, I was going to say I even show a couple of examples from some radar systems.
Okay. That sounds exciting. So as far as our emerging engineers in the audience and others who are in the audience that may not have had a chance yet to deal with the circuitry you're talking about and the high-speed challenges. What do you consider? Do you address what you consider high speed or high frequency? I'm sure you do a definition of these constraints. Tell us about that, and just briefly, because like I said, we don't want to give anything away, but just briefly what you're going to be hitting on.
Sure. Well, one of the things that comes up so often, especially in the video series, which I'm sure you're aware of, is we get asked often, when is the clock speed going to move me into high speed design realm? And it's obviously, as you're aware, it's not the clock speed, it's actually the rise time. And the rise time relates to the frequency content, and it's really the frequency content and thus the frequencies of interest that you're dealing with that puts you in that what you could objectively consider to be the high speed domain and the high frequency domain. And so that's really what the is used to show some of the analysis, especially when looking at an actual power spectral density for a signal. So that is going to be interesting because there's actually one great graphic that I show from a DesignCon paper, and I actually cite all my references in the slides. So anyone that wants to look at the stuff that's in those slides, yeah, definitely go look at the references because there's a ton of great information. But there's one really great slide that I show from a DesignCon paper that actually breaks down like what this power spectral density of a signal actually looks like if you were to measure it all the way out to hundreds of gigahertz.
Wow.
And so that's where you can really see why some of this high frequency stuff actually happens, is because the signal really is operating at high frequencies.
Yeah, and you had me at diagrams and pictorials because a lot of times, this is energy, right, that we cannot see without special equipment, and having the screenshots of the graphic of how things perform under certain conditions is key. So I'm sure you've got a lot of that, like you mentioned, and that's great. What are some other? I mean, Can you fish me out of your presentation just one or two or three points right now? Maybe somebody's got to drive home and can't catch the keynote. They've got something going on, can't catch the keynote. Let's give them three things so they'll tune in tonight at 11 on the recorded version.
Okay. So first, some tips with stack up. Okay, so some stack up designs that are amenable for high frequency. Yeah, that's one of them. Another one is a bit of an explanation on routing styles and how that affects losses, especially, and this is applicable to both high speed and high frequency. And then if you are going to go into the high frequency realm, some of the material constants that actually matter and how they affect the scale of the circuit. So I'll give you the answer right now real quick. Everybody says, low K dielectric or low DK dielectric. You always want to use low DK if you're doing high frequency. That's not necessarily true. There are cases where you actually want to do high DK, and I explain why that is in the presentation.
Yeah, very good. Well, that's a lot of information right there. This is going to be jam-packed, and I don't know if you in your speaking style, in your presentation, you have time even to maybe you'll be introduced, but let's learn a little more about the mind of Zach and the career of Zach and your career path. Lead us through where you started in electronics and how you got point to point where you ended up to where you ended up.
Yeah, so my background is kind of broad. I didn't go into engineering. I was actually studying physics when I first started doing anything with electronics. So I was doing my graduate degree. And my first circuit board I ever dealt with was just a little amplifier board for a bunch of sensors. So I had an environmental system that I was building. It was a test system for a chemical sensor that I was working on with someone in the environmental sciences department at my university. And that board was not production grade. It's your first one. It was my first time doing anything with circuit boards, but it did the job. It was down and dirty, and it worked. After that, I actually went into semiconductors and optics, and a little bit with electro optics. And then I had this long publishing career with with semiconductors and lasers and optics. My PhD research was on a topic called random lasers, which is this totally esoteric random electromagnetics thing. So I kind of come at this with really a fundamental background that actually really is ideal for RF. So that's kind of how I came into PCB design, was from the RF side. And then after hooking up with Altium and starting to work directly with the folks at Altium on content, and it just spun out of control from there. And here we are. The rest is kind of history. So yeah, my background is really more amenable and something that is actually really typical for the RF designer. I've noticed in my career there aren't as many RF designers. A lot more people are more on the digital side, maybe not always doing super high speed, but doing a lot of like embedded. And so that's what's really interesting, is having to bring the RF into it in so many devices. And I think that creates a lot of challenges for a lot of designers.
Right, but at the same time, the principles you're explaining and expressing and we're delving into are applicable to lower speed design performance, yes?
Yeah, absolutely.
In general?
And well, sure. And I think it's important to know, like, when do you need to start overthinking the design? And that's when you need to start worrying about, okay, what is the material doing? What do the material constants actually mean? When do I need to pick a certain type of material over another? And so an understanding of that kind of does help you figure out when you need to start really engineering the board at that level versus, hey, can we slap this together on a four layer board? We're just doing, I2C with a microcontroller and just have fun with it. So yeah, I think some people might want to overthink, but I also think sometimes people underthink and they build something, it might not work so well, they get into trouble. And so being armed with those concepts and that information is actually really helpful, because it helps you start to estimate, even just estimate and expect what happens as a design gets more advanced and operates at higher speed or higher frequencies.
Sure. So you deal with and help a lot of customers all over the place. We are one of them. So as customers come to you, they may have an existing board with, sometimes our engineers will create. We have a couple types. We have the production-minded engineers, which know they need to have loose enough constraints so that the materials can be procured anywhere in the world for volume production. But then we also have the rocket scientists, which may believe that their board will only function and perform with the exact same recipe every time. Let's riff a little bit on the two types of engineers, and if we address those, if you're addressing those types in your talk. In other words, do you sign up for a perfect simulation with a specific recipe, or shall you specify in your stack up means to allow a range of specifications that allow suppliers to, sometimes in production volumes we need to make substitutions. It's just a fact of life. What would be your take? What's your take on that?
So a couple of things. So first, if I'm just approaching it the front end of the design, I'm going to take something that I know worked before and use that as a decent reference point, especially if I've worked with the fabricator before, because I know that they can most likely fabricate that, and I can just send it in for verification afterwards, and then actually start doing the physical layout. So that's kind of one strategy, and that's why I always say in the videos, don't forget to call your fabricator. A wonderful catchphrase that I lifted from the great Mike Creedon. You were on that phone call, so you know all about the catchphrase. But credit to Mike Creedon for that one. So yeah, I do sometimes start with something that I know worked before, and we'll go that route. On some designs, the client will say, well, we want this. And you sometimes have to get into a debate with them and really moderate and not moderate, but really explain to them, like, this is why this is a better option. And we know that these guys can build this or something really similar to it. Otherwise, if you want to do, or actually, this brings up another point in the presentation, talking about hybrid stack-ups. Maybe you don't need to do all 6 of your layers as Rogers. Maybe it's just the one top layer that's just going to carry your high frequency or high speed signals. That's another option. And so you can take that to a fabricator and shop it around and make sure that they can build it. So I think it's more about understanding what to expect if things change, and then you can be flexible and really accommodate that. But getting those points addressed on the front end, especially when it comes to materials, and making sure that a fabricator is going with their standard stack up or has the stocks to be able to build what you need to build, that's where you should start. Because at the end of the day, like, CAD tools are great because they let you design whatever you want, literally anything. You could design something that is totally unmanufacturable, but you can still design it. But it's not going to matter if you can't build it. So focus on the build first. I come at it from the perspective that you mentioned where, perfect simulation and then worry about fab later. And I've had to change my mindset because my company, we do actually manage those types of projects where we have to get it into fab and help them walk through that whole process. Sometimes the client is not at all a PCB person. They're like a startup and they're software folks. They need to build a piece of hardware. They don't know anything about the hardware. And so they rely on us as the service bureau to guide them through that. And that means we now have to be, we have to have a steady hand to guide them through the manufacturing process. And that means approaching that on the front end, not on the back end.
Yeah, well said. Well said. Well, it isn't long here before your keynote, and I hope you're excited. I know you are. You exude excitement, and we're looking forward to this. And to our audience, I hope you've enjoyed this little behind the scenes, get to know Zach. We're connecting with Zach at this point, if you're not already connected. Thank you very much. We really appreciate the opportunity to talk with you. With me has been Zach Peterson, our last keynote speaker for AltiumLive 2022. He is the owner of Northwest Engineering Solution and Altium's technical consultant, doing all this great work with the podcast and the On Track podcast. So thank you very much for being with us. And for now, we're gonna sign off. This could be our last engagement between us host-wise, so I want to give you all another thanks for allowing me to do this and connect with you, Zach, to connect with you, and we're very grateful for the opportunity. Thanks so much, and we're looking forward to your talk, Zach. Thanks.
Thank you very much.
Yeah.
Well, gotta act fast. Sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. Entertainment. This event will be hip. We're in partnership with the folks from the IPC. Stakeholders unite and feel alright. Digging multi-show synergy. So let's all connect. Come on, people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine. Check us out. Virtual attendance. Yeah.
And learning. I learned quite a few things talking to Steve. I'm so sorry I called him Mark. Steve Marks. Anyway, I want to remind you that tomorrow is going to be start our keynote at 8:30, and we've got who do we have on board here? We've got Oh yeah, that's important. We've got our VP of Sales and Marketing, Lawrence Romine, who's going to be giving a keynote and making some announcements, and we're really looking forward to that. It's going to be called our Altium Live Connect event, as always. I'm winging it a little bit here. I'm sorry, it's this afternoon, but we're very glad you could join us today. This is probably going to be our last segment until tomorrow, so we want to remind you to tune in at 8:30 in the morning Pacific time for Altium Live Connect 2022, and we hope to see you there.